talked about in after reading our learning goal that really the key words today are precision and accuracy, and then we're going to throw into that mix tolerance, okay? So we'll start out with precision here. When determining precision, you may need to do some conversion to help you make a comparison. Well, we got to first of all know what precision is then. What is precision? That's why you have your books open. Right?
More detailed answer.
More detailed answer, okay? Detailed in what sense? Aaron?
Precision is the level of detail in measurement and is determined by the smallest unit or fraction of a unit that you can reasonably measure.
Okay, so in other words, the further out it is measured to the smallest unit, so if something is measured to the ones unit, and something is measured to the hundredths of a unit, which one would be more precise?
Ones, hundreds.
The hundredths, because that's a smaller unit.
Why?
Okay.
Oh,
So same thing as if you have dollar bills versus pennies, which is the smaller?
pennies.
Pennies, yeah. So when we're looking for precision, we're looking for something that is measured out to the smallest unit, and then if they're both measured to the same, you can't say one is more precise than the other. So the reason I say that we need to do conversion to help us make a comparison is, if they're not measured in the same thing, we can't say, oh, well, one is measured to the whole ones unit, and the other one is measured to the tenths, so the tenths wins out. Because we don't know if tenths of that will be actually smaller than wholes of the other. Okay, so we have to sometimes make a conversion to compare. Okay, so here's a couple of them. Which one do you think is more precise? The 4 33/100 grams or the 4,337 milligrams? Aaron, what do you think?
Milligrams.
Milligrams, why?
Because it's 1,000 milligrams in a gram.
Because there's 1,000 milligrams in a gram. Okay, I agree with that. How does that still make it more precise?
They're a lot smaller.
They're smaller, okay, but look at, we got grams measured out to the hundredths. Maybe they're smaller.
That one has 1,000 though.
That one has 1,000. That's not thousandths though, is it?
It's like 4,000. It's a lot bigger than like 100.
So it could turn out that they're going to be, but right now our reasoning isn't quite there yet. In other words, the milligrams are rounded, are measured to the what place value. What are the milligrams measured to? Sage? You had something else you wanted to say? Go ahead.
Yeah, if you switch the milligram number to grams, it'd be 4.337.
Okay. And then they be measured to the nearest, due to the what place? Thousandths. Is thousandths smaller than hundredths?
Yes.
Yeah. Okay, so that's the reason. We can't say it because right now we cannot make that decision because right now, in reality, if we did it as it stands right now, the milligrams are measured to the what unit? To the ones. That 7 is in the ones unit. This is tricky stuff, you guys, so you need to really care at the moment. That's to the ones unit. So it's kind of like, and then, so if you want to think of it as money, okay, so you have $4,337, the smallest, you don't have any coin, you don't have any cents, so if your money you're saying right now is to the nearest dollar, okay? This one is to the what place? Hundredths place, right? And so this one is measured to a smaller unit. Hundredths of something are smaller than whole ones of something. But the reason that we can't make, so if we were making the comparison right now, we would say that this is more precise, wouldn't we, the 4.33 grams, because it's measured to a smaller unit. But they're not, but we can't compare them right now, because it'd be like we're comparing apples to oranges instead of apples to apples. Okay? So we're going to change one of them to the other. Doesn't matter which one. You want to change the grams to milligrams or the milligrams to grams? Which one should we do? You get to make your call. You want to change the milligrams to grams? Okay, that's a conversion process. Okay, let's go. 4,337 milligrams. Just put it over 1. We don't have to put any label over that one. We're just making it into a fraction so we can use a conversion factor. And then, what did I hear you say, Aaron? How many milligrams are there in a gram, or how many grams are there in a milligram? Which
milligrams in a gram.
Okay, there's 1,000 milligrams in a gram. So where do we need those milligrams? Up or down? down. So we're gonna put the 1,000 milligrams down so that they'll cancel out. The milligrams will. And we'll put the 1 gram up. So let's see, we're using our conversion factors. And now we say we have grams, that's what we want, right? That's what we want to change it to. So we could go right to multiplying and dividing. So we have 4,337 grams over 1,000. Okay? And when you divide by 1,000, that's the same as moving the decimal point over 3 to the
Right.
left when you're dividing. When you're dividing, we gotta go left. So this is going to be 4.337 grams. So what we just did is we've just renamed our milligrams right here. We've just renamed them, don't cross them out. We've just renamed them as 4.337 grams. Now we can make the comparison to see which one's more precisely measured. The 4.33 grams is measured to the hundredths, this one's measured to the thousandths, which is a smaller unit of measure. Thousands. So we're going to say that 4,337 milligrams, as Aaron said in the beginning, is more precise. Because we have thousands instead of hundreds, and thousands are smaller. But you have to have something to support your answer. You can't just say, this is the one that's more precise. You have to give a reason why. You have to show some math, something that supports your answer. Okay? Anybody get questions on it? I don't want to leave you not understanding a part of what we just did. Okay, then let's go on to this one. The next one is a little bit tricky because now we have minutes and we have hours, and some of us treat time as if it's in the metric system and it's really not. And so, which one do you think is more precise right now? 67 minutes?
Yeah.
Okay, why? Any idea why? Aaron?
Because an hour is 60 minutes.
Okay.
And there's that 0.1, which is like a tenth of an hour. And then the 67 minutes, that's like an hour and 7 minutes.
Okay, so then that one's measured to the nearest minute, and the other one's measured to the nearest
hour.
Nearest hour. John?
I think the hours are more precise because 0.1 does not come out to a whole minute, and so it'd be like 67 point whatever minutes.
Say.
1.1 hour, 1.1 hours would be like 1 hour and 6 minutes.
1 hour and 6 minutes, okay? So then we could change, so he's saying we could make this into, this is really 1 hour, 6 minutes, because why? How'd you get 6 minutes? I think there's gonna be some people who are like, where do you get that?
Oh, that's common sense, I guess.
Okay, can you help them have the same common sense you do?
60 minutes or an hour, so divide that by 6.
Divide that by, or 6.
Or 10.
10 because a tenth of an hour. 60 minutes divided into 10 parts is 6 minutes for every 10, right? So now we're saying this is 1 hour and 6 minutes. Okay, now go ahead, Brendan.
1 over 10 multiplied by 60 over 1.
Okay, you could also do it as a conversion factor. You could take 60 minutes over 1 and take it times, so we could say 60 minutes over 1 times 1 hour over 10. Oh, I don't think that's what I want to do. I think I'm doing that wrong. I think I need to go back to what, tell me again, Brendan, how you did it. We'll do it your way.
1 over 10 multiplied by 60 over 1.
Okay, so you're just taking and finding it's 1/10 of an hour. This is 60 minutes in an hour. 60 minutes in 1 hour. You're just finding out that we have 6 minutes then 60, well, we'll take 60 divided by 10. So the same thing that Sage was just talking about. Take 60 divided by 10, you'll get 6 minutes. Okay, how does that help us? Now we got 1 hour and 6 minutes, we have 67 minutes.
Neither of them are
Aaron?
Well, now we're 60 minutes.
Now it's the hour and 6 minutes or the 67 minutes?
It would be 66 minutes.
So now it's, okay, but it is 66 minutes, but I don't think we want to think of it like that. Okay, Brendan,
You can turn 67 minutes into hours.
you change 67 minutes into hours. How would we do that? How would you do that? How would you change 67 minutes into hours? Would that be, could we do a conversion factor there? 67 minutes over 1 times, we want the minutes to go away. What would we put down here?
you'd put 60.
60, and we put an hour up here, right? Okay, now let's do that then. Go ahead and do that. Change it into hours, because the minutes are gonna cancel away. So we have 67, and this is going to be divided by 60. So we're converting minutes into hours. What does it come out to?
1.1166 repeating.
Oh. So it's not a terminating decimal, Sage?
You could just put 1 and 7 over 60.
Give it 1 and 7 over 60, you could do it that way. But since the other one is to tenths, to decimal, maybe it would be a good idea to do the same thing, decimal, right? Okay.
Then you can just go 1 and 6 over 60. And you just change the other one.
Okay, change the other one. Okay, there's another way to compare. We get all kinds of ways, but we still haven't really come to a conclusion then which one's going to be more precisely measured.
They're both the same.
They're
One's
the
just a
same?
smaller unit.
Well, we need a smaller unit. That's what
Okay.
precision says.
67 minutes
so then
comes
you
out.
have 60.
So this comes out to 1.1.
1.166 repeating.
It's just the 6 repeats?
Yeah, just 6.
Just the 6 repeats. So it's 1.116 repeating hours.
That has a smaller.
That's taken out further, isn't it? It's taken out further. Okay, the other way we could look at it too. So it does turn out to be the 67 minutes is more precise, okay? The other way we could look at it is this. 67 minutes is measured to the nearest minute, isn't it? Measured to the nearest minute. 1 and 1/10 hours. When we talk about a tenth of an hour, we're talking about being measured to the nearest block of 6 minutes. 6 minutes is bigger than 1 minute, isn't it? So when it's measured to a tenth of an hour, follow me on this, okay? Follow me on this. When it's measured to a tenth of an hour, it's measured to the nearest block of 6 minutes. The nearest chunk of 6 minutes. When it's measured in the minutes, it's measured to the nearest minutes. So 1 minute is smaller than a block of 6 minutes. So that's another way we can look at it. So it turns out in this one, so what you have to come up with a way. We came up with all. I just heard a what?
That made no sense at all what you said. I could not follow.
Okay, here we go.
You can follow it.
Let's try it again. When we changed 1/10 of an hour to minutes, it was 6 minutes, wasn't it?
Right.
Okay. So if they rounded, we don't have any idea if it came out to exactly 1 and 1/10 hour. All we know is they rounded it to the nearest tenth of an hour. Okay. So give me some examples of an hour, and some minutes that they could round to the nearest tenth of an hour. Give me some examples. 1 hour and 1 minute. Would that round to the nearest tenth? Would that round to 1.1?
No.
No. How about 1 hour and 2 minutes?
No.
No. How about 1 hour and 3 minutes? Well, wait a minute, that's halfway. And it's halfway. Wouldn't that one round up to the tenth of a minute? 4 minutes? 5 minutes?
Yeah.
6 minutes?
Yeah.
7 minutes?
Yeah.
8 minutes?
Yeah.
As soon as we get to 9, what happens?
No. It's
Now
denied.
it goes to 1.2. So in other words, we're rounding to the nearest block of 6 minutes. There's a chunk of 6 minutes that we're rounding to. So we're rounding to a bigger chunk of minutes, whereas the other one, we're rounding to the nearest minute. Not to the nearest 6 minutes, to the nearest minute. So that's smaller. And if you can't wrap your head around that, that's okay. Not everybody can. But just try and think about it on your own and see if you can eventually. But you have to come up with a way to be able to show support for the time, okay? Sage?
What if it wasn't rounded? It was actually just one, it was actually just was 1 hour.
1 hour, and then it was
Exactly 6 minutes.
And then it was
wasn't
6
rounded.
So if it was 1 hour, 6 minutes.
Yeah.
You're saying, instead of being,
Rounded from one.
Okay. then we would say that they are rounded, then we would say they are the same. One is not more precise than the other, okay? Because then that one is to the nearest minute also. Does that make sense? Okay. Okay, let's do the next one. Which of these do you think is more precise? 0.265 centimeters or 260 millimeters? Riley, what do you think? Millimeters, the 260 millimeters. Okay, why? Because it's smaller. Because millimeters are smaller than centimeters? Okay, but that isn't how we make our decision. We say which one's measured to the smallest unit, not which one is smallest. Which one is measured to the smallest unit? So I agree with you that millimeters are smaller than centimeters, but that doesn't make it more precise. Aaron?
So like you said earlier, the centimeters are to the thousandths, and the millimeters are to the ones.
Actually, the millimeters aren't even to the ones, they're to the what? They're to the tens. Whenever there's a 0 here, that would mean they actually rounded to the tens place. Okay? We have to assume they rounded to the tens place. So, okay, now what? So thousands are smaller than tens?
Yeah.
But they're not measured in the same thing. How can we be sure?
We'll have to do something to make them the same.
We gotta convert one of them. Yeah, we gotta
We have to do
we
something.
gotta do something. Okay, so which one do you wanna convert to what?
Millimeters.
Millimeters to, okay. So 260 millimeters over 1 times, we wanna go to centimeters. Anybody happen to know how many millimeters in a centimeter?
1,000.
No.
100.
10.
That's a 10.
10. See
Jeez.
how well you guys know the ruler?
Yeah,
The measuring
really
set of
smart.
the ruler?
Yeah.
There's 10 millimeters in
They
a
were all over the
centimeter.
place. I just
Okay.
wanted it out.
So we need the millimeters to be up or down?
Down.
Down, so we need 10 millimeters down and 1 centimeter up. And then we say, okay, the millimeter label can cancel. And I'm gonna have 260 centimeters over 10.
And then you cancel the
Well,
zeros off.
Dividing by 10 is, or yeah, you can cancel the zeros. Dividing by 10 is the same as moving the decimal point back 1 place. So it would be
100.
No, just
No,
26.
26.
I think it's just 26. It's 26 centimeters, okay? So now, it is measured to the what place?
The
tens.
ones place.
The ones.
The ones place. This one is measured to the ones place. We renamed this one right here as 26 centimeters. We renamed the millimeters as 26 centimeters. It's to the ones place, the other one is to the
Thousands.
thousands place.
So yeah,
I think the 0.265 is.
So the 0.265 centimeters is more precise. It is measured out to the thousandths, the other one only to the ones place. Okay. So it did, this time, if you would have gone with millimeters or smaller than centimeters, would you have been right?
Absolutely not.
No, absolutely not. So we can't have that kind of reasoning. We have to make sure we're comparing apples to apples. Not oranges to apples is right. Okay, you try the last one on your own then. Everybody do it to yourselves and we'll see what happens.
What?
Okay, I did both conversions so that whoever did whichever one, we can talk. Okay, So, if you converted the milligrams, if you renamed them, they got renamed as 0.033 grams. And if you rename the grams, they got renamed as 33 milligrams, okay?
Whoa.
So,
They're like the same.
oh, they're like the same. So is one more precise than the other?
No, they're both precise.
And they're both, so neither, we're gonna say, is more precise. They are measured actually to the same standard, to the same precision, okay? Neither is more precise. But we have to have something to support that. So you have one or the other. You either converted the milligrams into grams and compared, or you converted the grams into milligrams and compared, and then said, well, they're exactly the same. Or better yet, this isn't what we should say. They're exactly the same. We should say they are exactly to the what?
To the ones or to the
The
thousands.
Yeah. So if you converted to milligrams, they both ended up to the nearest ones. If you converted to grams, they both ended up to the nearest thousands. So that's where the precision comes in. Are they measured to the same unit of measure when we compare them?
So wait, could they like not equal the same but still come out to?
Right, so let's just say the other one had been 37 milligrams, okay? What would that have come out to in grams? 0.037 grams. Well, now that's not the same as 0.033 grams, but what?
It's bigger.
No, but it's to the same
It's to the same thousands and then the same
They're
ones.
measured to the same thing. They're still both measured to the thousands.
So neither would be more precise.
Neither would be more precise. Right. So precision is tricky. You have to make sure that you're talking about which one's measured out the furthest, to the smallest unit of measure in between the two of them, or however many you're comparing. Okay, let's move on to the back side then, where we need to be, it looks like you need to flip to page 76 in your books. But before we actually do that, let's talk about, and maybe that's on that, I think that's on that same page, let's talk about accuracy then. What's the difference? Why is there such thing as accuracy? Isn't accuracy and precision to you kind of mean the same thing?
Kind of, yeah.
So what is accuracy then? Because guess what, there is a difference.
What?
There is a difference between precision and accuracy. We've decided precision is measured out to the small, which one's measured out most precisely to the smallest unit. Aaron, what's accuracy then?
Accuracy is the closeness of a measure value to an actual or the true value.
So which one of the measurements is closest to what they want it to be?
Okay.
Okay, so I say, I want you to give me $100.38. If somebody gives me $100, someone else gives me $100.10, and somebody else gives me $100.40, who is giving me the closest?
The 40 cents.
The 40 cents, they got the closest. Even though the 10 cents and the 40 cents are really, they're measured to the same thing, to the nearest dime, that has nothing to do with accuracy. Accuracy says which one is closest to the one you want it to be. Okay? So let's look at 2A. Let's look at problem number 2, check it out. I want you to read through that and study it a little bit, because we have to answer 2 questions. Everybody looking at, check it out, problem number 2 at the bottom, towards the bottom of the page. Okay, what are they measured to? What are they
16 ounces.
Well, that's what they want it to be, right? 16
Yeah.
ounces? What do the scales measure it to? Do all the scales measure it to the same level of precision?
No, one is 16.3 ounce, one is 15.8, another one is 16.07.
Oh, so they're not all measured, but they're all measured in ounces.
Pretty much, yeah.
So we don't do any converting.
No.
No converting needed here because they're all measured in ounces. So we need which one is most precise, that's part A. Which scale is measuring most precisely, A, B, or C?
C.
C, why C?
Because it goes to the hundreds.
Okay, so it goes out to the smallest unit of measure, so we're gonna say scale C is most precise because it measures to hundredths, which is smaller than, what are the other ones measured to?
Tenths.
Okay, so we get to pick scale C for precision because, and you need to write this out so that you understand. Kate, join in. Scale C is most precise because it measures to hundredths, which is smaller than tenths. And now we have to decide which scale is most accurate and why. What's the reason? Okay, which scale is most accurate and why? Tyler?
B,
You think it's scale B. Why?
because it'd be easier to get 0.2 ounces than it would be any other ones.
It would be easier to get. What's the definition for accuracy again? Is it which one is
Closest
easiest?
to what you want.
Closest to what do they want it to be?
16 ounces.
Okay, so let's do some math here. A, what is its measure? What is?
16.3 ounces.
Okay, so we're gonna say 16.3 because that's bigger than 16, right?
Yeah.
Take away the 16 that we want it to be. How far away is it?
0.3.
It's 0.3 ounces off. Okay, ounces off.
So we want to get the lowest?
Okay, we want the one that's going to be the smallest, don't we? We want the one closest to it.
Sure.
Okay, so B. What did B measure it as? Right?
Wouldn't it be C?
I don't know. That's what we're trying to find out. Because, but you think it's C? Okay, we'll go with Tyler thinks it's B. You think it's C? Okay. Okay. What did B measure it to?
15.8.
15.8. Well, that's smaller than 16, so we're going to subtract it from the 16. We're always going to take the bigger and subtract the smaller, and that is
0.2 ounces.
0.2 ounces off.
C.
So, which one's closer right now?
B.
B is closer right now. It's winning the contest right now.
Oh.
Okay, how about scale C? What did it measure it to? Riley?
It was 16.07.
16.07, and that's bigger than 16, so I'm going to put it first, and that would be
0.07.
0.07 ounces off. So this is, or we can think of it like money. 0.3 is like 30 cents. 0.2 is 20 cents. This is 7 cents. Which one's closest to 16?
Scale C.
7
Scale
cents.
C, yeah. Scale C wins the accuracy one, not because it was also precise. One can be more precise and one can be more accurate, but in this case, scale C won both of the labels. Yay! Okay. So scale C is most accurate because, and we show it right here. There's our work proving it. We don't just say which one's most accurate, we prove it.
Joy.
Okay? So, anything we should talk about more with that? So do you know the difference now between accuracy and precision? Okay, because now we're going to talk about tolerance. And you guys all know what my tolerance level is. About 0, right?
Put it up here.
Not very high, no.
What?
Okay, page 77, check it out. Tolerance says, here's what I'll tolerate. This is it's like a window of time. So if instead, I do have a tolerance level for you guys, okay? My tolerance level for you guys having homework done is it's due the next day. So you get 24 hours before, and then you get 24 hours after to finish it up, and I'm talking about tolerance for not getting ER, okay? So you get it done 24 hours before, you have 24 hours after. If it doesn't get done in that window of time, what happens? ER.
Yeah.
So of course the goal is that you get it done ready for class on time. That's the middle of the road. So you have this, I have to get it done for the class the next day. So from that time period, okay, so there's a tolerance there for it, Blake. Thank you. So we're going to talk about, when you think of tolerance, think of it as a range of what does it have to fall in? What does it have to fall in between here? So let's look at problem number 4 on page 77. Check it out, problem. I was hoping you guys had done all your reading, so like, I'm just assuming then that you knew something before you came to me today. But I guess you don't, so we'll just have to try our best, okay? So problem number 4 says write the possible range of each measurement round to the nearest what? 100th, if necessary. Okay, so we have 4.1 inches that has a plus or minus, what percent?
5%.
Okay, they will tolerate a 5% tolerance. So does that mean that we could add 5 to that?
Or subtract.
No, what is 5% as a number
Oh, it's
actually?
5%. Multiply.
Okay, so we really have to take 4.1 and we have to multiply it times its decimal name. Write that down. We have to take 4.1 and multiply it times 5%, but 5% has to be treated either as a fraction or as a decimal. Well, I'm gonna guess you're gonna choose the decimal. Calculate that, please, and round to, what did it say, nearest? 100th. So round it to the nearest 100th. It is approximately
205.
Well, 205 is not to the hundredths. 5 is in the thousands place, the zero's in the hundredths, so should that 5 change that 0?
0.21.
It should be 0.21. I also should be able to assume you guys know how to round before you get to me. Okay, so that means it can go either way. It can be 0.21 less than 4.1, so we would subtract it from it. We're saying it would tolerate it being under that much. So what would that be then?
3.89.
3 and 89/100ths. That's the low end of the range. And then we have to add it to it to get the high end of the range. So the high end of the range is 4.31. So the range of tolerance, that's what they wanted us to give, and we know what the label is. It's measured in what?
Percent.
What's it measured in?
Inches.
Inches. Okay, so we're going to say 3.9 inches to 4.31 inches. There's its range of tolerance.
Wouldn't its range be like 0.42?
The right smack dab in the middle should be what they wanted it to be. So 4.1, if we did it correctly, should be right smack dab in the middle of 3.89 and 4.31. Okay. Okay, you do C then. Okay, C, 4C, 85 milligrams plus or minus 0.5%. 85, okay. You have to move the decimal point back 2 places. That's 0.5% is all. So 0.5% is 0.005, and rounded to the nearest 100th, what do we get? 0.43, okay. So that comes out to 0 and 43/100. That's how much the tolerance is. So it can be that much less, so we'll do a subtraction problem with it. And we show this before we calculate it. And we do an addition problem with it. And we show it before we calculate it. And then we will write our range of tolerance after we get those. So I'm thinking this one should come out to 84.57. And the other one is 85.43. Am I right? So our range of tolerance is actually 84.57. What was it measured in? Milligrams to 85.43 milligrams. There's our actual range of tolerance. So we have to calculate what the percent of it is, first of all, in other words, how much can it vary by? Then we add, subtract it and add it to the, what is the ideal to get our actual range. And what should happen is our, what they want it to be should fall exactly in the middle between the ends of our range of tolerance. Okay, then there's one more thing we have to do. We have to rewrite specified tolerances as percent. So look at, they tell us, here's what they will allow. They want it to be 60 ounces, but they will allow a variance of 1.5 ounces. So we need to find out what percent 1.5 is of 60. So how would we do that?
1.5 divided
No, 60 divided by
by 1.5.
1.5. Wouldn't that be how we would have, oh, you were right, no, I'm wrong. I'm not thinking straight here. We do have to take how much, what part, the part is 1.5 divided by the whole. 1.5, the part divided by the whole, 60. Just like our grades, if we got a 1.5 on our quiz, divided by 60 points possible, that wouldn't be a very good quiz score, would it? Times 100, change it to a percent. What percent is this? You got a 1.5 on the quiz. Out of 60 points possible, what did you score? That's a bad score. What is it?
2.5.
2.5%. Whoa. That would be a bad quiz score, wouldn't it? Okay. So, now rewrite the tolerance with a percent sign rather than the ounces. That's what we're doing. We're saying we're rewriting the tolerance. It was given to us as a percent, or as ounces, and we're going to change it to percent. So we write 60 ounces plus. This should have right here a minus underneath it. Would you add that? I don't know why that didn't show up on the. Is it on your notes? This should be a plus or minus 1.5 ounces here. So plus or minus 2.5%. So there it is written as a percent tolerance rather than as in the ounces. So up in those other problems in number 4, they gave it to you as the percent. And we did it the other thing, and here they're giving it to us as ounces and we have to do the percent. Okay?